So it's given that the mth term of a harmonic progression is n and the nth term is m. We need to determine the mnth term of the given progression. Let us begin. So we'll start the problem by considering an arithmetic progression. So let us suppose that the first term be a and the common difference be d, such that the mth term of the arithmetic progression will be given by a plus m minus 1 times the common difference d. So this is the mth term of the AP. This is not the harmonic progression. This is the mth term of the AP. Now, if we want to find out the mth term of the AP, what we have to do is take the reciprocal. So this is going to be the mth term of the harmonic progression, and it's given here that this particular value is equals to n. So that means we have am equals to 1 over n. So if we replace the value of am with a plus m minus 1 times d, we get the equation a plus m minus 1 times d equals to 1 over n. We're going to label this as equation number 1. Similarly, if we consider the arithmetic progression and find its nth term, so the nth term is going to be given by a plus n minus 1 times the common difference d. However, in our problem, we are provided with the nth term of the harmonic progression. So the nth term is given by 1 over an and is given that this value is m. So we have am equals to 1 over m, or simply a plus n minus 1 times d equals to 1 over m. So let this be equation number 2. So what we'll do, we'll use equation 1 and 2 to find out the value of the first term and the common difference. So let's do 1 minus 2. So here we have m minus n times d on the left hand side, and on the right hand side we have 1 over n minus 1 over m. So that becomes m minus n over m times n. So solving for d, we get 1 over m n. So this is going to be the value of the common difference. So what we'll do, you can use either equation 1 or 2 to find out the value of the first term a. So here we have a plus m minus 1 times the common difference 1 over m n. So that's given by 1 over n. So we have a plus m over mn minus 1 over mn equals to 1 over n. So if we solve for a, so here this term and this particular term will cancel out. So we have a equals to 1 over mn. So now we have the value of the a, the first term, and the common difference d. This is for the arithmetic progression. So let's use the first term and the common difference to find out the mnth term, not for the HP, but we will be finding out the mnth term for the arithmetic progression. So we'll do the arithmetic progression. So it's a mn, meaning the mnth term. This will be given by a plus m times n minus 1 times the common difference d. Let's substitute the value of a with 1 over mn plus mn minus 1 times 1 over mn. So this will be equals to, let's find the value. So we have 1 over mn added to mn over mn minus 1 over mn. So for the first and the third term cancels out and we are left with 1, which means that the mnth term of the arithmetic progression is 1, but we need the mnth term of the harmonic progression. So the mnth term of the harmonic progression, which is simply the reciprocal of the mnth term of the arithmetic progression. So this is going to be equals to 1. So this is the final value.